And the board also? Both, right?
Yes, sir.
Okay, thank you very much. So, in the today's lecture, we will talk about the learning, and then we'll move to the machine learning and then the deep learning. Okay. Everyone not everyone, the most of you use the machine learning, deep learning in the today's world, especially for the project and all. Even for the research purpose, we use the machine learning and the deep learning quite heavily. But one thing that I see which is missing is the understanding of the algorithm of the machine learning or algorithm of the deep learning. Okay, so unlike the other lectures, here I will focus on understanding this machine learning and the deep learning with very simple, small example. Okay, so even for the larger data set, you can able to write the code yourself, because only you have to think for the logic. You have to develop the logic. So obviously, when we work on the example with the pen and paper, we have taken the small example over here. Okay, but for the larger data set, you can use the coding things, or the many libraries and everything is already available in the Python or in the MATLAB. Okay, so that you must use. But before that, you should also understand that what is it, how is it working. Okay, so that is the important differences with respect to the other lecture. If you want to know the reference for this talk, first let me show you the reference. That is the recently published book. Okay, not in full details, because the machine learning itself is a 1 semester course, at least 1 semester course. Deep learning is itself 1 semester course, 40-hour lecture course. But here we have only 1 hour or 1.5 hour or 2 hours. So we'll try to give you the motivation as much as possible, and also give you the understanding. Okay, and if you are interested more about this area, you can explore and you can read yourself the research paper, or you can contact us, or you can develop the project yourself. Okay, there are other topics also for computing, privacy and security of things data, like the blockchain thing we have discussed over here, elliptic curve cryptography we have discussed in the chapter 8, and finally the application. So this is a very good book for the undergraduate students, even for the PG students. So I'm going to cover this chapter over here. All right, so I hope you have enough motivation to study these things. So before moving ahead, let us define what is learning. Pushpenji, I want to make this lecture interactive. So is that fine? Are students allowed to speak up, right? Yeah, okay. Because I don't want to give the monotonous lecture that they will fall asleep after some time. So I hope it will not happen in my lecture. Yeah. Thank you. So the student define what is learning. What is the learning of the kid? How does a kid learn? Those who 2 years, 3 years, 4 years old, how do they learn?
Seeing new things and experience.
Yes, seeing new thing and experience. Like we show them the different types of chair, table, different type of houses, the different types of books, and based on the experience, after some time, after 3 years, if you ask them that, okay, what is this? They will able to clearly or correctly will tell you that, okay, this is the chair, this is the table, this is the computer, this is the laptop, this is the mobile phone. One famous thing you can see, it just comes with experience. You see, if the child who born in 90s, they have not seen the mobile phone, right? We have not seen the mobile phone. We have seen the mobile phone in late 2000, right? We were not knowing there is something called mobile phone, right? We don't know even that something called laptop is there. We used to heard the computers, right? There is something called computer course used to be there in the school days, right? But nowadays, even you ask the kid, my son is there, 3 years old, and he always say कि पापा मुझे लैपटॉप चाहिए and मैं मोबाइल फोन लूंगा. मोबाइल फोन नहीं, मोबाइल बोलता है, you see, in Hindi. So you see, how does he learn? Especially based on the experience, you know that we are working on the laptop, we are working on the mobile phone, we are working on the tab. So they also understood that this is something new, right? But if you ask the 90s born kid or 80s born kid or 60 born kid, they don't know even what is the computer. You see? And this is defined by the American computer scientist, the Tom Mitchell.
Sir, the screen went off. Sir, the screen went off.
Okay. I don't know. Maybe because of the network. I have not done anything. Let me share once again. Yeah. Can you see the screen now? Okay.
Yes, sir. Yes, sir.
So, in nutshell, how do we define learning? As some of you have told, that based on the experience, if you gain more and more experience, there are some task T is there, some task T is there, some performance, some task T, and their performance is measured by the P. Performance may be in terms of the, let us say, classifying the objects. Let us say, just let us think in terms of the kids. They classify different things, right? So that performance, the P, should increase with the experience. What I wanted to tell you that, we use the whiteboard also. If we have some task T, task may be classifying the table, chair, laptop, tablet, like that. Given this task T, if we show them more and more examples, the performance will also increase. And this is what the learning is. You see, it's very simple. Now the question is that, what is E? How to get E? E is the experience, as I already said. This is the experience, okay? And the T is the task. This is your task. And the P was performance, you already know. So you can get this experience, obviously, by showing the different examples, Show them the different examples, and based on seeing the different examples, their experience become more and more. I think some screen gone off, right? Once again. No. Okay. No, some sound I heard, so I thought that it went off or what. Okay. So you can see that if you here in the machine learning, we have the examples, and the machine learning, the ML, the machine learning, simply learns by the examples, simply learn by the experience. It is like you ask something to a 10 years old guy, some related to the experience, or you ask something related to the old guy, 40 years, 50 years old. Obviously, those who is 40 years old, 50 years old, they have more experience because they have seen the world, right? They will give you the practical experience that, okay, if you do this, you will perform, or if you do this, you will perish, like this, right? So how do they gain this thing? Obviously, based on the experience, based on seeing the different things, okay? And that is not there in the newcomer because they are just new in the world, right? And with the experience, as you become older and older, as your age become more and more, you will become experienced one. You see? So that is the definition. So in the machine learning, it is simply in short, it is called the learning by the example. Okay. Unlike the signal processing, some of you might be knowing the signal processing or the communication. There we had actually the closed form expression. We have, where we have the expression, some mathematical expression is there. And if we want to implement it, we used to write the code for this, the closed form expression. Okay. But those things, unfortunately, is absent in the machine learning. So sometimes people see this as a black box also. But although some of the insight you can able to get it, okay, if you think clearly or if you see the things carefully, or when you refer to the research papers, okay, it is not fully black box. Okay, there is some intuition behind that. All right, but it is unlike this one, the signal processing, then we have the expression I already mentioned. So here, only thing that will increase the performance is simply the example. This is the heart, you can say. This is the heart of this, this machine learning and deep learning. Although I don't know how the heart looks like, but this is the shape people used to draw. Okay. So now let us define these three terms. The first is called the artificial intelligence. There we automate the intellectual task performed by the human. It means simply that whatever decision is taken by the human should be able to take by the system, by the computer, and that is what the artificial intelligence is. Okay. The subset of artificial intelligence is the machine learning. In the system gets trained. I already mentioned it, that what is learning. But I talked about the learning of the human. But in the same way, the system should be able to also get training and also should learn. That is what the machine learning is. Okay. Earlier, this thing was not popular. I can tell you before around 2010 or something. I also heard the term around 2011. This machine learning. So I thought also, frankly speaking, that it is something machine learning may be related to this electrical engineering, pure power system or machine, something like that. Okay, so there that time, even I had also not realized that this is so much powerful that we will when I use this for the real life application. All right. And you can see nowadays that everyone wants to go for the machine learning. Even the industry, many of the industry working on the machine learning, especially for the automation purpose. Okay, so that you can reduce the manpower. You don't have to write the codes for each of the individual tasks. You don't have to hardwire the things. Rather, the thing should be flexible over here. The same code will be used for the different types of data. Maybe the healthcare data, maybe the finance data, maybe the smart city data, like that. So we are not going to change anything in the algorithm or something or the coding. We just call the function and try to get some output, or some people write the code also from the scratch. The subset of machine learning, is the deep learning. You might be aware of that. There also the system gets trained and learned. System also learns the thing, but here we use the concept of the multi-layer perceptron for the complex task. So you can clearly see that the deep learning is the subset of machine learning, and machine learning is the subset of artificial intelligence. So in other words, the broader umbrella is artificial intelligence, which is the superset of machine learning, and machine learning is the superset of the deep learning. So deep learning is at the heart. You can see from here. Okay, and here are the different, what is machine learning, what is the motivation, what is the different application. That thing we have already discussed just now. So the application of this machine learning is the different for the different application for the smart environment. This is for the smart environment, as you know, smart environment. And here in a smart environment, I mean the environment can be the city, the smart city. It could be the healthcare. You see, transportation, like that. Here I have listed very few of them. But there are plenty of such examples of the smart environment, and all the automation things is coming into the play. Nowadays, the automation. Let us say the automatic lighting and all in the house and all. This become very much, very common. But I can tell you, this just 10 years or 8 years back, 2010 or 2012. This thing was not that popular. We have not seen even that thing, right? So I have seen that thing in the automatic lighting and all in the some airport, in the Delhi airport, or also in the Oxford University. I've also seen first time. So I was just surprised a little bit. Oh, this when I going inside the corridor, the lighting is getting on, and then you are going away, it is getting off. So it was really fascinating at that time in 2010, 2012. But nowadays it become quite common. Okay. And all this thing is possible, this automation is happening because of this Internet of Things And at the heart of this Internet of Things, we have the machine learning. Because in the Internet of Things, in the IoT network, there are 3 layers. The first layer and the bottom layer is called the things layer. Things mean the sensor, okay? The sensor which will collect the data from the environment, okay? Like someone is walking on the corridor, okay? Some person is there. So what is this? This is the data, and that will be sensed by the sensor, okay? That is your things, and things will take this data. It will send further to the network layer. Let us say the gateway. Because the range of the things and all is very small, because it is a tiny resource constant device. But we use the gateway at the network layer, to form a larger network, okay, so that you can able to send the data from one end to other end, and the distance between these 2 points is very large, okay. On top of this gateway, the gateway further sends the data to the communication, and here actually the communication is there, communication and control, you can say, communication and control. And then after that, we have the computing over here. So the machine learning, and then finally we will have the application layer where you will get the user interface, okay. So the machine learning actually, even in the Internet of Things and all, it lies here. This is where the ML or DL lies, okay, because the heart of the IoT network, again, you can see that is the computing. There are other things also, the communication, you cannot undermine that thing, because that is also very much important, for the short distance communication or for long distance communication. For short distance communication, we use the Bluetooth, but for the large distance communication, there are many protocols, like the cellular network also be used. Even for the LoRaWAN, we also use in the IoT network. Okay, so I will not get into the details of other things, because it itself is, that it will take 5 hours or the 10-hour lectures, So here I will focus especially on the computing. Okay, if you are interested in the other parts, you can refer to the book, or you can contact me. Okay. So I hope you have now the motivation. So the machine learning, you can see that there are 2 types of learning over here, machine learning. The machine learning, the ML, is there 2 types. One is called the supervised learning, and the second one is called the unsupervised learning. There are other categories also, but that is called the semi-supervised. That is the combination of both supervised and unsupervised. It is called the semi-supervised, and the final one is called, the reinforcement learning. Although in the research and all, we use mostly the reinforcement learning, semi-supervised learning, unsupervised learning nowadays, because there is some reason for that we'll discuss now only. But still, in order to understand the unsupervised learning or the other learning, semi-supervised or reinforcement learning, first we should have the foundation of the supervised learning, so that it will help us in understanding the other types of learning. So in the supervised learning, you can see that although the slides and all are there, but I don't prefer the slide, okay, because I want to make the things interactive, okay. So that you should be able to understand it, you should be able to get the feeling that what is really happening. I want to make it like a real class. Okay, so in the supervised learning, there are 2 types of things are there. Things, not the sensor. Okay, 2 component, you can say. One is called the data, and one is called the label. Okay. Let me take one example. Let us say the COVID cases only. Okay, COVID cases. On the x-axis, let us say we have the number of days, or you can say the month. Okay. On the y-axis, let us say we have the number of cases. All right. Sorry, spelling is wrong. CASES. Okay. And you know that it is follows some pattern, like it goes like this, then goes up like this. Now we are somewhere over here, and it will further decline. Okay, let me just give you the example, then I will ask some question based on this. See the question carefully. That is one question. Second question is that, let us say they take some samples, let us say they take the blood sample, okay, or they take the sample, or they take the swab sample, something like that. So based on that, they will be able to tell whether you are this positive, COVID positive or not, right? So you will get the two types, either the positive or you will get negative. Some cases may be undetermined also because of lack of sample or because of some error during the collection or something goes wrong in the process, where you cannot able to tell whether it is positive or negative. All right. Can you tell me in this example, in these two example, example 1 and this is example 2, which one is the data and which one is the level? Which one is the data and which one is the level?
Example 2 is the data and example 1 is the level.
Sorry, in example 1, what is the data? With this?
Data is the number of cases and level will be month.
Very good. Level will be month. Okay, I will come to this point. And in example 1?
Positive and negative will be data and the samples will be level.
Sample will be level. Any other body? Anyone else? What is the data in the example 1?
3 datas are there: positive, negative, and undetermined.
Okay. Anybody has any other answer? No. A very simple question, right? In machine learning, deep learning, we should first understand what is my data, what is my level. Can you interchangeably use it? I will tell you, you see, the blood sample is your data and the level is the positive, negative or undetermined. Because in the supervised learning, we feed both the data and level. Data will be sample, as I said. This is your data, and corresponding to this data 1 for person 1, what is the case? Whether the positive, let us say, for data 2, person 2, what is the corresponding level? Let us say positive. Okay. Data 3, what is the cases? It is positive, negative. Let us say negative. So like this, we provide this sort of thing, etc. In the training phase. This is in the training, training. Okay, in the testing, there are two phases. In the testing, we give you some new data. Let us say the data n+1, and I will ask you whether it is positive or negative. Okay, and this kind of problem, you should be able to tell if you are, actually if it is positive and you are able to classify into the positive, then the error is zero error. But on the other hand, it is actually the person is positive, but it is giving the negative result. That is non-zero error. Can you tell me if you are positive, if it is giving positive, it is fine. But if you are positive, you are getting negative. What is that called? You are actually positive, but the machine learning algorithm is classifying them to be negative. What is that called?
Non-zero error.
No, non-zero error is fine, but what is the name of this metric? Have you heard the name of false positive, false negative, true positive, true negative.
False negative it will be.
Falsely it is giving you the negative, right? Although you are not negative. Or if you are negative and you are getting positive result, what is that called? Falsely you are getting the positive.
False positive.
False positive.
False positive. And finally, when you are negative and you are getting negative, it is called the true negative.
Yes.
Positive, positive, it is called true positive. You are positive, you are getting negative, it is called falsely negative, falsely positive. You see? So the goal of the algorithm is to maximize the TP and TN. This should be maximized, and the FN and FP should be minimized. Okay, this is one example, and this problem into classifying into the different positive, negative is called the class. This is called the class. This is called the class. Okay, and this problem is called the classification problem. Okay. Now, can you tell me what is the name of the problem for the example 2 now? Is it a classification problem or something else?
Something else.
Something else, sir.
Something else. And that is called, here you see that you have the month 1 data corresponding number of COVID cases, some data correspondingly a number of cases like this. You see? So what is called, what do you think, what should be the name of this problem? We have already studied it. Sorry?
Representation?
No, not representation. You have studied in your BTech first year or third semester, numerical methods. Is it there, this course? Numerical methods?
Yes, sir.
Yeah. So there, what do we call it? I want to relate this machine learning to your basic mathematics and the calculus, nothing else, so that you will get enough motivation rather than just discussing the black box high level thing. I don't want to just discuss high level. I want to go into low level so that you should get the motivation. What is this method name? What is this called? We also use this terminology in the daily life, right? That's what could be the number of cases after 1 month. Or when the peak will reach, there are many, the people who is working on that and they publish the result. Also, some of them are getting correct, some of them are giving the incorrect result. Then they say that, no. What is that problem called? The number of cases till 2nd February up to this point. Or this point, let us say that peak is at hand. Okay, so that we will feel mentally relieved that it will going to come down. Okay, it will come down. Now I will ask you that, let us say you have the data of after every week, weekly data you have. Okay, let us say something 1st January, this is 7th Jan, this is 14th Jan, like this, and so forth till 2nd Feb. Then I will ask you that, boss, I have the data only of the 1st Jan, I have plotted this one. For 7th Jan, this is the data. But I don't have the data in between. Because what number of cases corresponding to the 2nd Jan to 6th Jan. So what you will do? You will try to predict the number of cases in between the known value. First, Jan and 7 Jan and correspondingly number of cases, this you already are aware of. This is the known thing. But in between that, there is a question mark. So if you try to predict in between the range, in between the given range, it is called interpolation. Okay. On the other hand, you have the data till 2nd Feb. Now I'll ask you, what would be the number of cases on 1st March? Then obviously you have to predict. So since the point of interest is outside the given range is only from 1st Jan to 2nd Feb. The point of interest is outside this range. This is called extrapolation. Extra means outside, inter means inside. Now can you tell me, in which case you will get the lower error, in interpolation or extrapolation? What do you think?
Interpolation, sir.
Interpolation. Why?
Sir, because we are knowing the value and low error. Yes, sir.
The low error is fine, but you know the value of what? Why the interpolation should give you the lower error? You are going in the right direction.
Because boundaries are known.
We are predicting between the known values.
Yeah, not we know the data. We know we are predicting in between that, and that is least likely to be in error.
Yes.
But if you something you predict after 1 month or 1 year, obviously your result will be very poor, right? Because in between that, you know that you have the data over here, you have the data here, there. You know that it is falling down. Some error will be there. Some people might interpolate as a curve. Some people might interpolate as a single line, a straight line. Some people interpret it like this. So because of that, you will get some error. Sorry. But that error is still lower than here because you don't know what will happen in the future. Right? So that is the thing. And this problem in machine learning, there is a different name. It's called the regression. And both regression and classification, you can see that we have both the data and the corresponding level. It falls under the category of the supervised learning. Okay. Second one is called the unsupervised learning. In the unsupervised learning, you don't have the data. You don't have the label. Here we have only the data. We don't have label is absent, and that is the reason why in the research community this thing is quite popular as compared to the supervised learning. Why? Why is it like that? Which one is more challenging? What do you think? Unsupervised learning or supervised learning?
Unsupervised learning.
Obviously unsupervised learning because here you have the data. You have limited data, you can say. You don't have enough the label, or you don't have label at all. So here you have to work with the limited evidence, you can say. Right? And obviously that is more practical, and that is the reason why for the real life problem and even for the research people, they focus on these 3 types of learning. In semi-supervised learning, we have the combination. For some data,
Sir,
we have the level, yeah, and for some data there is no level.
Extrapolation is like outliers.
Extrapolation is not outliers. No. Outlier and extrapolation is different thing. Outlier is, let me define outlier then. Extrapolation means it is like predicting the value of f. It is a function of f of x. On the x-axis we have the x, on the y-axis we have the f. So this x is outside the range. Range is x naught to, let us say, x10, right? And if I ask you what is the value of f at x11, this is extrapolation. This is extrapolation because you want to find the value of f for x and which is outside the given range. But outlier is which does not follow the pattern. Outlier, let us say, our marks, let us say you have given the exam and I'm the teacher, I'm checking the answer sheet. Okay. Many of you, let us say there are 10 students, many of you got the marks in between 90 to 100. Some, let us say, this number of students is, let us say, 6 students who got between 90 to 100. Let us say 2 students who got marks 85 to, let us say, 90. Let us say there is 1 student who got the marks between 60 to, let us say, 70. There is 1 student who got marks below 30 marks. Which one is the outlier? Outlier means does not follow the pattern. You can think this as a class outlier, extreme outlier. This can be also, you can treat as outlier, but it is not extreme. You see, so measure of outlier is measured by, by something called mu plus minus 3 sigma. You know what is mu, what is sigma? Gaussian random variable?
Yes, sir. Yes, sir.
Gaussian random variable, bell shape, right?
It is.
Here you have the mean.
Yeah.
That is my mu. And what is sigma?
Sigma. Yeah. Sigma is standard deviation.
Very good. Standard deviation. What should be the unit of a standard deviation? Let us say
it is the square root of the variance.
So what should be the unit?
Unit? I don't know.
No, you can tell the answer. A square root of something is square, right? There is some 1 by n also, you add it also.
Yes, sir.
So let us say marks is square or meter is square, and then you take the under square root, what do you will get?
That is meter.
Meter or means original unit.
Yeah.
Yes, sir, original unit. Yeah.
So this measures the spread. You see, why I have asked this question so that you should understand rather than just remembering the things. So this measures the spread. So let us say this is my region plus minus 3 sigma. Plus minus 3 sigma. The mean is, let us say, 60. For this example, let us say the mean is something, let me take some value. Let us say 85 marks, 86 marks is my mean. And the standard deviation is coming out to be, let us say, 7 marks. So if it is 86 plus 7,
yes, sir.
Or if it is between 86 minus 7, so what is 86 minus 7? It is 79.
79.
Right? And this is how much? 93. Am I right?
3.
So if it is the marks is between 79 and this 93, then it is normal data. Normal data. Not normal distribution.
Normal distribution.
Not normal distribution. Let me not use the normal data. Let us say what should I tell? The data which follow the pattern. Okay. Normal distribution means the zero mean and the variance is 1, normal distribution. And this is the n. That shows the normal distribution. Okay. But if your marks is even 93 plus, let us say the marks, let us further do the subdivision. In 90 to 100, the 5 students got the marks between 90 to 92, and there is 1 student who got the marks, 100 marks. Which one is the outlier now? One outlier, extreme outlier, we found 30, and this is also outlier.
Yes, sir.
Okay, so here
either maximum value or minimum value.
Yeah, extreme side.
Extreme maximum or extreme minimum.
But if there are many values nearby, then that also cannot treat as a outlier. There are different measures for that. I have here mu plus minus 3 sigma 1. I have discussed a very basic one to detect the outlier, but there are many other the ways. Okay, and obviously the performance will be different depending upon the problem. You understand that's what is outlier?
Yes, sir.
Outlier is different from the noise also. Outlier and noise are different things. So I hope you know that. If you don't know, then you can explore.
Sir, but in regression, we do not use any extrapolation.
No, we
I
do
haven't
it.
used any extrapolation.
No, but you can use that. Let us say number of COVID cases, you are fitting the curve, right? That for the data till 2 days, you know the corresponding number of cases, and you have the curve. Then if I ask you that what is the number of cases after 5 days, so that is extrapolation. That is,
Sir,
and that is a part of
we
regression.
always do regression on the known data, but how can we use a regression on unknown data?
Unknown data we can do it. I can tell you the example. Let me explain that. You see, this data is there. Same example, let us say number of days
It
one.
will be like overfitting the data.
No.
We use on unknown data.
Overfitting, underfitting is different things. I will come to that. Let us say number of cases for one is this data. For second day, data is something like this. Third day, data is somewhere over here. Fourth day, the data is somewhere over here. It is going down. Now you have to tell that what is the number of cases on fifth day. So one way could be, let us say you fit some curve. You fitted some curve over here. Some curve like this till this point. And you got the equation. This is f, this is x. So you got the expression for, you know, if you know x1, you know corresponding fx1. You know x2, you know corresponding fx2. You know x3, you know corresponding value. x4, you know corresponding value. So based on this thing, x and f, you can get some model, right? If that you can easily do by using the, you know, the least square error, that is called least square. So in the least square, what we do, we try to minimize the error between, the actual
value and predicted value.
Means observation and the theoretical x, and we try to minimize it. Okay, and after minimizing, you will get equation of fx, and fx is coming to be something x square plus 2x. Let us say for this. Okay, and this you got in the training page, right? And this x square plus 2x you got based on this data. x1 correspond to 1, x2 correspond to 2, x3 correspond to 3, x4 correspond to 4. It may not be in the order also. Here I just taken an example for the simplicity. Okay, now I will ask you that what is the value of f5? Can you not able to tell it? Just think in terms of your school days mathematics. What is f5? What is the number of cases at day number 5? Day 5.
Yes, sir, we can find.
You understand?
5 square plus 2 into
Yes,
5.
sir.
That's why I'm explaining the very basic thing that people often miss this terminology and they just call the function in the Python without knowing anything. Especially by the BTech student, I have also realized, I have seen that, I'm telling you from the experience, and that is the reason why I'm focusing on the very basic of calculus and all. You see? All right? So you can do the prediction, or you can do the other way problem also. If you tell you the number of cases, some number of cases like this, I will tell you what is the number of day. You know f for x5, but I will tell you, I know f, but I don't know x5. So how will you do? How will you solve this problem? We have to simply what? We have to simply invert this thing. We have to write x in terms of function of f. Right? Here things may be looking complex. Let us say f is equal to 2x plus 3. That is the simple case I am taking. So I will give you the number of cases is something, some value is there. That is denoted by, let us say, some value number of cases, let us say 1000. 1000. Okay, don't think that this is the zero axis. My axis is over here, let us say. So this is the 1000, and I will tell you that, can you tell me what would be the number of day? Okay, on what day you will achieve the number of cases to be 1000 given this trend. So from this trend you got this function, and I'm interested in getting x, so 2x plus 3, and from there you can easily get x, right? Because this is the linear, that is the reason why you can get non-linear. Also there are different ways to get the x. You see, so that is also the regression. You see, that is the reason why I
Yes,
told
sir.
you that
Only if we
data
know
level.
the relationship between X and Y, then only we can find the.
Yes, so the machine
Yeah.
learning, the regression in the machine learning does that thing only. They try to fit the model.
Yes, so what if we don't know the relationship between X and Y? Then we can predict the value.
They will do this thing only at the back end.
Okay.
Otherwise, without that, it is not possible because it's not a magic, right? That they will tell you that okay, this can happen, right? It is the science, you know. So everything is based on the data and based on realistic thing. You see, many people claim that okay, this peak will attend on this date, and you might have observed that they have changed their things. That okay, no, peak is not attending, so they told that okay, it is delayed by 1 week. Have you heard it or not?
Yes, sir. In weather forecasting also.
Or weather forecasting also, they will tell you that it will rain today. Many days it becomes false because of the lack of data. The function you have learned, but that function is not that much, the experienced one. You have got some model, but that is very crude one. Like weather forecasting, in UK, they will tell you when I was in Oxford in London, they used to tell that after 1 hour it will rain, and it used to rain. There were gusty wind, and there used to be. The reason was that they have deployed the sensor, sophisticated sensor at many places to collect the data, the wind direction, wind speed, everything, and based on that, their prediction or forecasting is much, much better. Okay, so prediction or that is the regression in machine learning depends upon how well you have trained your model. If you don't, let us say the data is following the curve, and if you fit the straight line 2x plus 3, obviously this will give you the wrong result, right? It will not that accurate. Okay? You have any doubt? You can feel free to ask any point of time. Okay, it is not the formal lecture that you need to ask the question at only at the end. Even in the formal lecture, I allow my student to ask and stop me at any point of time.
Sir, how can we train our?
How can you train our?
Means machines that about data.
Learning, training means, let us say for the given X, learning the F is will be done by the F, this machine learning. Let me take you the example. How to learn this F? You have asked a very good question. Let me come to that point. I think I have discussed all the things that is mentioned in the slide. It's not that I am discussing something else. This thing, everything we have discussed. This is also we have discussed. This is the classification, regression. Although the example is different, the price and the mileage. Okay, KNN. I will come to the KNN classification. Before that, you have asked this question. So let me ask this data, linear regression. You have the X, you see over here, and you know the corresponding Y. So I will just use the calculus. You see over here, you have Xi, you know Yi, means X1, Y1, X2, Y2, X3, Y3, and so on. So our equation is Yi is equal to AXI plus B. Yi is equal to AXI plus B, and I will go from 1 to n. What is the value of n over here in this example? In this example, what is the value of small n?
4.
5.
No,
5,
4, 5.
5.
1, 2, 3, 4, 5. Now, based on this data, we have to learn. Some of you have asked the question, sir, how the machine learning will learn. We have to learn. So what machine learning will do, let us come to that point. And once we learn the model, I will ask you what is the value of y when the x is 10. Because you can clearly see in this data, x is equal to 10 is absent. Okay. So let me come to that point. I will just use a school grade mathematics calculus. I will try to minimize the sum of the square error. This is the observation and this is the theoretical. I assume that the data follow the linear model in this case. In this example, but if it is not there, your first job is to find that which model, either the first order, second order, polynomial, sum of sinusoid, or any exponential, different forms of the model. That you have to first determine that which which model it fit best. Here I assume that the first problem is solved, let us say, otherwise it becomes too much complicated. I know that this data follow the linear model. Okay, otherwise you have to find that thing also. So what I'm trying to do, I'm trying to minimize the errors, square error. Can you tell me why I'm trying to minimize the sum of the square error? Error will be yi, and when you bring to this side, left side, so yi minus axi minus b whole square. Now can you tell me why I'm not minimizing only the error, square error? Why I'm not minimizing only the error? Why am I minimizing the square error? Can you tell me?
Square error is the energy.
Yeah, it is energy in the error signal. So energy, it is positive or negative? It will be positive.
Error can be both.
Yeah, error can be both positive and negative.
Positive or negative? Yeah,
negative. But if you simply take the sum of the error might become 0, right? Plus 2 meter error, minus 2 meter error becomes 0. But error is error. Although it is not desirable, if you simply sum the error, you will get 0 meter. You will think that everything is best, but it's not. So what we'll do? Either we have to take the modulus of this value or the sum of the square error. You see, in that case, you will get the positive value 4. In this case, you will get 4. Error direction does not matter. This is the center point. Either you are this point plus 2 or you are at minus 2. It does not matter. You are not, in both the cases, you are not close to the actual value. This is my ground truth. And you are over here. You are over here. Okay. Ideally, we want to have at this point either plus 2 or minus 2. Both are not okay for me. You see, I'm not comfortable with either. That's the reason why we go with the sum of the square error. But before going to sum of the square error, some of you might be wondering that why do we not take the absolute sum by taking the mod value, mod operator? Why most of the places you might have heard the name RMSE. You have heard the name? What is RMSE?
Root mean square error.
Root mean square. There also you see there is a root. Root mean a square error. Right? This is the root. Mean means you will add all the corresponding error. Mean means you will add and then you will divide, let us say by number n, and then you have to take the square. So why do we not use the absolute? Just think in terms of the calculus of 12th class. Let me draw it. A square one, you will get the curve, let us say like the parabola. Absolute sum, you will get like something like this of mod x. This is x square. Can you see the problem? Now you can tell the problem. You might have studied it in the limit or in the differentiation. Do you see some problem in the first one? When you use the mod sign or when you use the square one? No idea. Let me ask the question like this. Which one is continuous? First or second?
Second continuous.
Second continuous. First is not continuous?
No, sir.
It has discontinuity at origin.
Are you sure?
Yes, sir.
It has discontinuity. What about differentiability?
It is not differentiable at 0.
Which one? The first or second?
First.
First.
First is not differentiable, you see. That is the major problem.
Yes, sir. Yes, sir.
And you know what we want to do? We want to minimize the error or maximize the error?
Minimize the error.
Minimize. How to minimize the error? In calculus
Taking
again?
differentiation and equating it to 0.
Yeah.
And equating to 0. Yes.
And set it equal to 0.
Yeah.
Same thing I am doing like the calculus of high school. Here we are taking the partial derivative. The reason is that there are two parameters A and B. So when you take the partial differentiation with respect to B, A will be constant. When you take with respect to A, B will be constant. So you can clearly see. So can you see now the problem that it is not differentiable, this function, the mod function, sum of the absolute error. And if it is not differentiable, can you able to do this derivative operation? Can you able to use the concept of maximum minimum? You can't.
No.
Yes.
This is a major reason. Although people use the sum of the absolute error in some context for some application because of some reason, but in general, we prefer the sum of the square error over the sum of the absolute error. Okay, so let us now quickly summarize what is the derivative. If we take the derivative of this whole square, what do we get? How to get
Difference
the
of sums.
Yeah, difference of sums. So how will what do we get? What is the derivative of something square?
2x.
2x, very good. So 2 may be there and x, everything is there. So, and set it equal to 0. So 0 by 2 becomes 0. So forget about 2. Then 2x. X means yi, sum of yi, axi minus b, right? Sum of b. Anything else? Into what? Using the chain rule of derivative.
Into differentiation of yi minus axi minus b.
Yeah, very good. Into differentiation of this yi minus xi minus b. And what is that differentiation? It is the partial.
It will be equal to -1.
-1. Very good. -1 because this is constant, this is constant.
0.
And it -1. 0 by -1, minus you again bring to the other side.
0.
It does not matter to us. So it's simply what you get. What? Sum of yi, a outside, sum of xi, and summation of b n times. When you add some constant n times, what you will get?
N times that constant.
5, yeah, you add 500 times. So you will get 100 into 5. This is 100, this is 5. This is the first equation. Although you cannot get the b now because this is the function of both a and b, right? So what we have to do, we have to stop at this point and then we have to take the differentiation with respect to a and we will get some other equation and then we will solve these two equations simultaneously. Okay, because here you cannot get the expression for b. Can you get the expression for b? You cannot get. You will get b, but that will in terms of a. It become like the chicken and egg problem, right? If we have only one equation. But here since we have the two varied parameter a and b, so if we solve these two equations together, then we will be able to get the value of a and b. Our goal is to learn the model that I promised. Here, what I promised that we will learn this model x square plus 2x or 2x plus 3. It is a linear model, so we will get some sort of x plus b. So in model, we should know that what is the constant. Otherwise, how will you get the f? If I don't give you these two, I will keep it x square plus bx. If I just give you 5, x is equal to 5, but you don't know b, how will you get the prediction? You won't get. Okay? Now, you can tell me now. I have given you the enough clue and all. What is the differentiation of this quantity, sum of the square error with respect to a? Answer is also there, but you need to understand. You might have studied this kind of thing in statistics. It might be there in the curriculum in third sem or second semester of BTech.
Yes, sir. 2 into yi minus axi minus b.
Yeah. Hang on. So 2 was there, so I brought to the other side. 0 by 2 becomes 0.
Yes, sir. 0. Yeah.
Yi minus axi.
Yes, sir.
And the b. What else?
Into minus xi.
Minus xi. Because you are taking the derivative of this chain rule. You have taken the differentiation of power, now differentiation of the base. So this is constant now, and differentiation of minus xi with respect to a will give you minus xi. Minus again is there, you bring to the other side, it becomes 0. What you left with xi. Earlier you had yi, you multiply by xi, it becomes xi yi, it is the summation. Summation is a linear operator, you can break it into 3 terms. And here axi was there, but when you brought another xi, it becomes square. And here b was already there, but when you bring xi, it becomes xi. If the constant was there, so we have pulled it out, the summation. Now can you solve these two equations together? These two equations to get the expression of A in terms of xi and yi.
Yes, sir.
So you can clearly see xi yi as it is, axi whole square minus summation of xi b. So from here I will get b will be equal to summation of yi minus summation of axi divided by the n over here. We have simply substituted the b from the first equation into the second equation and you got this expression. You can clearly see now that everything is in terms of xi and yi. It does not depend upon b. Now a will be given by simply, you can see summation of xi, then you take the LCM, n will multiply together over here, so it becomes n into this term, minus what? Minus xi yi over here, summation of xi into summation of yi. And when you take a common, so you will left with other side xi square minus summation of xi whole square. Is this point clear or not? Let me clean so that you can clearly see everything. Is it fine or not now?
Yes, sir, fine.
Anybody has any problem over here? They can raise the issue. No issue. So we got A. Similarly, you know from the 10th class, you got A. We know the relation between A and B. You substitute the A over here and try to get the B. Same line, you will get the B like this. This I am leaving for you as a part of the homework. Leaving for you. Okay. And now you know xi yi. You know xi yi. Just simply substitute from this table. You will get ei to be equal to 0.9 and b will be equal to 2.2. And this is my model learned by the machine learning. So you see. Now for the given new x, you can clearly get the y. Did you get it? Who has asked this question, sir? How the learning will happen?
Yes, sir.
Yeah. So this is one of them. You see, there are many methods, many problems, and I cannot cover everything in 1 hour. Yeah.
So one more method was on gradient descent for minimizing.
Yeah, gradient descent also you can use. That we especially use when the things are non-linear. Here things were separable, you can see. Things were very simple. I started with very simple example, toy example, you can see.
Yes, sir.
But whenever you get non-linear thing where you cannot get this expression in very closed form way, because in this expression you can see that A and B was in the closed form way, right? Some expression is there, you have to simply substitute. In that case, you can use the gradient descent. Gradient descent again is the basic one there. You have to take the gradient and then your update expression will be something y new will be equal to y old plus some learning rate multiplied by the gradient. But nowadays in the research community, people have gone for the stochastic gradient descent. Instead of working with all samples in the gradient descent, that is called the full batch, in stochastic gradient descent, you will work with the small, only one sample at a time, so that the convergence is achieved very faster. You know, nowadays people are going for the Adam also, you know, adaptive moment. So there are many optimizer for this calculating these things, you know, but the basic is from the linear regression only what I started with today. Okay, you can explore more and more if you are interested in this area, because
So
this is for
Adam is
lectures.
like adaptive boosting.
Adaptive boosting, but that also you can use to get the parameter. Moment based regression. Just search it. There is many research paper. If you cannot get it, I will provide you. Contact me back later on. I will give you my email ID is Sudhir, and let me write down. I'm talking about now research level. So far I have discussed the very basic thing, so that to motivate you, my email ID is sudhir@iitp.ac.in. If you want to do the further research, collaboration, or project, you can contact me. For more details, I can again tell you. I'm telling you because I cannot cover the things in 1 hour. It is a webinar kind of thing, so I try to give the motivation. You see. So this is here, the website here, you will get all the information. You will get all the information over here, like the publications. So here you can see the latest paper, there we have used it. The things what you're talking about, you will get in this paper. Which one was that? Yeah, this one. A multi-stage deep residual network for biomedical cyber-physical system. This has been published in IEEE System Journal. Okay, so for the research purpose, you cannot use the things what I taught. What I taught is just for your basic understanding and motivation. Further, for research purpose, you have to explore the new and new thing, because every day people are proposing the new things. All right, so that you can see over here. If you are interested in that, you can click on the paper. All the information is over here. Okay, teaching and all is not related. This is my current lecture, communication networks, that I am teaching. Some notes video lecture is also available. So if you are interested, you can refer to that. So see over here that I wanted to highlight. Yeah, you see. Adaptive moment, ADAM, optimization technique for parameter estimation. You see over here. And we have used it in this way. It is slightly changed version of this gradient descent. In gradient descent, we don't have beta 1. We had only mt-1, vt-1. And we just multiply the gradient with this sum learning rate. But here, slight change, beta 1. Here we are taking 1 minus beta 1 so that the sum will be always 1. Sum of the two weights. And these are the updated correct bias and the updated parameter. Slight, you can say the variant, you can say not exactly the variant, means slightly sophisticated than the gradient descent. Got it? So you can explore that. Now,
so here we are taking ReLU as activation function instead of
no, again, activation function is different thing. The Pritham will discuss about the now activation function. Pritham, we start from the basic.
Okay, sir. Okay, sir. So I'll be giving the example, and along with that,
yeah, because some people are confused that they are relating the gradient descent with the activation function. So it's not. There is a like somebody was confused with outlier and the extrapolation. It's the same way. It is also different. Then we start from very basic of the things.
Okay, sir.
And they explain the Python thing, activation function also, and give the brief introduction to deep learning. Okay, don't give into too much details. This paper is published in IEEE IoT Journal, Human Activity Recognition. This paper is, if you are interested, you can refer. This paper is there. Which one? Where is that one? This one, paper number 53. Okay, but he will not discuss all the things in that much detail because it is a research level and you people are from undergraduate. So he will give you the basic understanding, and further if you are interested in the research, you can contact us.
Sir, I'm then sharing my screen, sir.
So now it's over to Pritham. Feel free to ask the question, don't worry, and ask any point of time. Oh, I will be there. I will be there.
Okay, is my
if
screen
some meetings or something comes, then I will let you know. Then I have to drop. Otherwise, I will be here.
Okay. Sir, is
Uh, Thank you very much. Although I could not cover everything because it's not possible to cover the 40 hours lecture in 1 hour. But here I try to give the motivation, and if someone is interested, they can contact us further, or they can do the research project with you people also, right? So that was the purpose, not just giving the high level thing like people do in the webinar and all. Okay, so that's the reason why I'm going to the lower level, little bit lower level. But my plan was to cover this KNN and all, also KNN, how to do the classification using KNN, NAB base. But unfortunately, because of the time, I could not complete that portion. But in future, if I get the opportunity, I will explain, or if you are interested, I can deliver. There is no problem. Yes, see, I joined here in Patna, IIT Patna especially. I was getting the offer from other old IIT just to help the people in the Bihar, especially the Bihar Engineering College that was not that good early in 10 years, 20 years back, right? So here I want that our students should be at par with the students of the other states or the other countries. Not only the Bihar, means the people in the vicinity, right? Because in the state college, obviously more number of students will be from the Bihar, but people are from other places also, like this Pushpendraji is also from, I think, MP, right? You see, so let us learn something and let us raise our level to some high level so that we can do really good thing and we can make a really good image.
Yes, sir. As Sudhir sir has explained the basics of the AI and the machine learning things, so if you could remember the basic block diagram at the beginning, sir has shown one thing that deep learning is a subset of the machine learning, and machine learning is also a subset of the artificial intelligence, right? So I'll be discussing an application of the deep learning. So somebody was asking that regarding the activation functions and regarding how the learning happens. So I think I can explain something while showing this example of a Python code. But let me say, in terms of, I'll be discussing an application of deep learning, that is human activity recognition. Now, before discussing that thing, let me say why we use Python. So there are many programming languages, right? So why Python is so much used, so much in the, it is gaining importance nowadays. The reason is that as compared to, if you see this thing, I have shown one thing. There are two types of languages, programming language actually. One is the compiler based and another is the interpreted programming language. So as Python is an interpreted programming language, means the moment it is very user friendly, it is very easy to learn, although there it is much linguistic, means like if you see, I think many of you must be knowing the C programming, right? So in C programming, you have to write the machine code in terms of the when you write the language, you write the code, it gets compiled into the machine code and then it gets ready to run. However, in case of the Python programming language, it is an interpreted language, means it is very user friendly. If you write np.min, so then it will just generate the min. If you write sum, then it will obviously give you the summation of, suppose you want to generate the summation of two numbers, 3 plus 5, just type 3 plus 5, it will give you the result 8. You don't need to generate any code that a equal to b plus c and then generate the sum. Like this you don't need to do, unlike the C or C++, those compiled programming languages. So this is the ease of using Python. However, it is used as at a much higher level, and that's why it has a number of huge set of libraries to make it fit for the artificial intelligence domain, specifically for the data science, then the machine learning and the deep learning algorithms. Although it is a bit, it is bit more language oriented, but if you see the code length, it will be 1.5 times less than the Java. And also another advantage, it is an open source. You can download the Python from the net. It is an open source software. You can download and you can just code. And there are different IDEs, the integrated development environment for the programming. I will be showing you in the Jupyter notebook. You can see that the Jupyter, it is written, it is a notebook. And there, this Jupyter notebook, one advantage is that Jupyter notebook, if you are even offline mode, you can work on the Jupyter notebook. And there is another online notebook also, that is Google Colab. So Google Colab is another notebook, but you need to have the internet connection. But there is one is that although Google Colab will provide you with a 12 GB GPU, but there is one big disadvantage is that once your internet connection goes off, your code, the part of the code that you have run, that will get lost. So that's why I prefer Jupyter notebook. Also, you can use the other platforms like Spider, PyCharm. Now, Jupyter notebook and Colab, these two are the notebooks. Means these will, if you see the extension of this code, I will be generating. This is .ipynb. However, if you use Spider, the extension will be .py. And another advantage of Jupyter notebook and Colab is that you can generate the snippets, code snippets. Means one part of the code you can write, and you can check that whether that part is right or wrong. You can get the result. However, for Spider and all, you have to generate the full program, and then only you can understand where the program is going wrong. So that's why I am using Jupyter notebook. Now, TensorFlow and Keras. So these are the different libraries. As I mentioned, that there are a number of libraries. Now, these are the libraries that are running at the back end. TensorFlow, it is the open source machine learning platform, and Keras is also another library, but it is specifically a deep learning library, if I say, not machine learning. So, Keras is specifically built for the deep learning models, and it is built on top of the TensorFlow. So now I'll be going into the deep learning thing. So as I've shown here, from AI, then comes the machine learning, and then further deep learning. Now, the major advantage of using deep learning is that, so in deep learning, you don't need to extract the features specifically. Like in machine learning, there are the algorithms, the KNA, k-nearest neighbor, naive Bayes, and many others, random forest, decision trees, whatever be there. So there you need to extract the features from your data first. Then from those extracted features, you may need to select the features, and then you have to feed those features to your model. So those feature extraction techniques like PCA, principal component analysis. So that requires a lot of mathematics. However, in deep learning, although those mathematics things goes deep inside the model, you don't need to separately do the mathematics. So this is, although for research purpose we need to analyze what is happening deep inside and also frame our own deep learning models, but so it's not that easy from the purpose of the researchers. But as a college level project, you can use deep learning. That I can suggest you. And also deep learning will yield some better results as compared to the traditional machine learning classifiers. Now, somebody was saying what are the activation
So
functions?
what about the features in deep learning?
Yeah.
So features, we can automatically detect the features in deep learning, or we have to provide?
No, that I'm saying that you just need to, here the thing is something called like plug and play. You just need to design the model. Here you don't need to, means most of the cases, not all cases. In most of the cases, you don't need to extract the features separately. That's why I am going to explain why you don't need to extract the features. Because the model, this is, if you see the name, it is deep learning. So why the name deep? Because of the depth of the neural layers. So say there is one neural layer, second neural layer, third, fourth. So there are a number of layers. So in each layer there are imagine that the vertical there are the number of layers. So
you are saying about the hidden layers, input, output,
right,
and the hidden layers in between.
right. Layers means hidden layers. So
Okay.
here all of the hidden layers of neurons. So in the each layer there are a number of neurons. So those number of neurons that you need to decide how many number of neurons will be there in each layer. So that is the kind of tuning of the hyper. I think you those who are familiar with the programming might have heard the term hyperparameter.
Yes, sir.
So that hyperparameter needs to be tuned, or that is the thing that you need to a kind of brute force thing that we do in kind of the deep learning. However, there is a lot of mathematics behind that thing. So we are also doing research how to means instead of tuning the hyperparameters in a trial and error method, how to specifically put the exact number of hyperparameters. Like you can put the number of layers as 5 or 6. That we should not, ideally as a researcher we should not do. There are some techniques that we need to frame, that we have also framed, that how we should design our model. And in those hidden layers, through those hidden layers, the backpropagation thing happens, where the learning and this backpropagation thing leads to the learning of the model. Okay, so here you don't need to extract the features in deep learning. Here you just need to put the input, feed the input data to your model. Through the depth of the neural layers, the model will learn all by itself during the backpropagation. And somebody said gradient descent, right? So that gradient descent is the
Yes, sir. We use gradient descent in
right.
backpropagation.
So that is the thing, that through the neurons, say there is layer 1, layer 2, layer 3, and layer 4. Okay, so the backpropagation happens through layer 4 to layer 3, then layer 3 to layer 2, then layer 2 to layer 1, and finally to the input layer. So what actually gets updated? There is actually weight assigned to the, between each layer. Between layer 1 to layer 2, there is some weight, say, called W1 to 2. Then between layer 2 to layer 3, there is some weight called W2 to W3. So these W1 to W2, then W2 to 3. So these all gets updated by backpropagation. So that thing here, I have mentioned here the advantage of deep learning: import model, feed data, tune it, run, get better results without separately extracting features mostly. Okay. So I'll be giving since this is I am having a short duration of time, so I'll be just explaining a deep learning model and its application. So I have used basically LSTM. So LSTM is something called long short-term memory. So basically there are a number of deep learning models like CNN, then LSTM, then GRU. So LSTM basically right. LSTM is actually a subcategory of RNN, recurrent neural network. So what does actually LSTM do? LSTM works on time series data. If you see this figure here, HT minus 1, then HT and HT plus 1. H actually this pictorially represents the hidden state, and T minus 1, T, and all these things, these represent the time instants. Okay, so inside us, and these xt minus 1, xt plus 1, these are the samples at different time steps. So that is fed to our model. So inside a single LSTM cell, there are actually basic 3 gates. It operates. How does an LSTM operate? So these are actually a neuron. Okay, so you consider this to be a neuron. So here I am, the name as it suggests, long short-term memory. So it will, if you see this, there are 3 cells, right? So it will remember something, memory. So the memory is used to remember some information. So it is used to remember the information. If you see here are 3 cells across 3 cells. So that's why it is called long. And it is called long short-term memory. Why short-term? Short-term because it will, there are 3 gates, as I mentioned: forget gate, input gate, and output gate. So it will not remember the entire information for a long duration of time. It will remember all the information for a short duration of time. That's why it is called short term. And for a long duration of time, it will remember the only the required information. Okay, so that's why it is called long short term memory. So forget gate, what is this forget gate, input gate and output gate? What are these gates actually? Somebody told I heard that activation function, right? So these gates are the here, this sigmoid, if you can see this sigmoid symbol, 10H symbol, these are the activation functions. And these activation functions, these are actually the forming the gates, FT. So this is the sigmoid activated some input value. There is some equation. I'm not going deep into the equations. Just remember that there are three gates. This is the forget gate here. This is the input gate here. And here, this is the output gate. So based on these three these three gates, the LSTM cell remembers which information is important for our context to get some classification output, and which information is not unnecessary or redundant, and accordingly we will get that output. Okay, so remembering and forgetting, and then presenting that information at the output layer. So that thing will be happening in an LSTM cell. Now I'm coming inside the code. So here, this is the before running generating some code, you need to, since I told I am using some libraries, right? So here, this NumPy and the pandas, these are the libraries basically, and Keras and TensorFlow, these are the also the libraries. So TensorFlow is running at the backend, as you can see, using TensorFlow backend. So this runs at the backend, and on top of that are built these NumPy and pandas and these Keras, all these things. And why I am using Keras? Because I'm not building since this is an application of deep learning, so I'm not generating this LSTM from the scratch. I'm just importing from Keras. Keras has the inbuilt these deep learning models like CNN, LSTM, convolution, 3D, everything, RNN, so GRU. So from Keras.layers, if you see here, from Keras.layers, I'm importing the LSTM. And there are, you can find that some other things also I am importing, like sequential, dense, flattened, dropout. These are the intermediate layers that I required to, for framing my model accordingly. So I'll be discussing that thing. Now, from NumPy, we are importing mean. From NumPy, we are importing STD. STD is the standard deviation. So NumPy is basically the library used for the matrix and array operations and the arithmetic and logical operations. So for that, you require the NumPy. And pandas, it is actually the panel. Pandas is coming from the term panel data. Okay, so from panel data, from there you are getting the name is termed as pandas. It is a library. There you are importing the data frame. So every data you have, you need to highlight that data in a. You need to visualize data first. Whatever program, be it machine learning code or any deep learning code or any ordinary data science code, the main thing is to visualize the data. Without visualizing the data, you cannot just call the model and or frame the model. Nothing will happen. So you need to visualize the data in 3 dimension first, and then accordingly you need to modify the structure of the data in 2D or 1D or maybe in 3D also based on your requirement, and accordingly you need to run your code. Similarly, there is another library called sklearn. So sklearn is actually the scikit-learn. So from there we basically import the metrics, like as I discussed, that we need to see the model accuracy, right? So the accuracy score. Also, there are some other metrics like precision. Rick sir was telling, if you remember, true positive, false negative, and false negative. So all those frame all with all those terminologies, these metrics are basically calculated. It is precision, recall, F1 score, all these things. Now
Confusion matrix.
So from the confusion matrix, I have also confusion matrix. So confusion matrix is basically a matrix that comprises of those values: true positive, true negative, false positive, and false negative. And from those values, you need to that is actually matrix. So from that matrix, those values are obtained, and from those values, you can calculate accuracy, precision, recall, and F1 score. Okay. So now another main thing, why should we not only stick to accuracy? We have to also see the other metrics like precision, recall, and F1 score. The reason is that only accuracy, it might not be sensitive to some to some outliers. So if you see in an accuracy, the formula is true positive plus true negative divided by all the values, means true positive plus true negative plus false positive plus false negative. So there you might be having some the sensitivity of the model may not be understood to the false values. So in order to understand the tendency of the model to respond to the false values, you need to calculate this precision score and the recall score. Basically, the precision score gives you the indication of the false positives, and recall score gives you the indication of false negatives. So I'm telling this in short, not going into the detailed formulas. You can find the formulas either in net or any formal machine learning book or deep learning book. And F1 score gives the mean of these precision, 1 by precision plus 1 by recall is actually 1 by F1 score. So from there you can get these metrics. Now first you need to, as I told, these
Sir, we have already imported the confusion matrix from scikit-learn.
Yeah,
but what is the need of importing the precision, recall, and it comes under the
specific matrix? No, I am importing this because if you import only confusion matrix, you will only visualize the confusion matrix only. But specifically, if you want to get the value of precision score, recall score, and F1 score, you need to import these metrics. Like
then we have to only call the precision score, then the precision
you
score
have to. You may not call the confusion matrix if you directly, because these are already there in libraries. A library has, see, in a library you may have one book comprising a big story, and you may have a small book comprising a chapter of that, right? So you can take anything from the library. A chapter, if you require, you can take the small book also, and if you require the entire book on some subject, you can take the big book also, right? So this is the same thing. So you can import. So sklearn is the library here. So you can do the only import precision if you want only precision. You can import only recall score if you want that only. And confusion will give you only the matrix visualization. So that is the thing. Okay. So now I am going into the code. So I am using the UCI HR University of California Irvine Human Activity Recognition dataset. So basically that dataset consists of was recorded by 30 participants, and they performed 6 activities. And the 6 activities were walking straight, walking upstairs, walking downstairs, and then sitting, then standing, and then laying down. So these are the 6 activities that we need to detect. So what I do here, we first load the single file by as a numpy array. Here, if you see this def, this is actually for the function we are creating. So where we are loading the file. So this, we have loaded the file. Next, we from the file path I have mentioned here. So read CSV. I am reading the file in the CSV format. The file is actually stored in the same folder where this code is stored in my computer. Here, this AI with this UCI HR dataset. If you see, here are this train test. I have already separated the dataset has already separated training value, the testing value, and also the labels value. And if somebody is willing to use the machine learning thing, the features value is also there. Okay, so Now, next, I'm loading the list of files as a 3D NumPy array. So here I am calling all the, if you see here, I have called this load file. The load file I have invoked under the load group, this load file. Okay, so this is another function, load group I have created. So I am arranging I am visualizing the thing, the 3 dimension. So here, next, if you see here, this is another function where I am loading the full data set. Now here, please notice here, the file names I have mentioned here. To there are 6 features. Okay, so one is the accelerometer data, and one the data is actually in terms of the accelerometer data and the gyroscope data. The X, Y, Z, 3 gyroscope axis data, the body acceleration X, Y, Z, 3 acceleration data, and the entire body this gyroscope, both acceleration thing, means total, that is called as total acceleration, means where the gravitational acceleration is also considered. So in total I am having 9 features as input data. So this note that this feature is not a statistical feature. This is actually, this feature I am telling, this is the input data to the model that I will feed. So this data I am framing, I have visualized the data first, and then I am loading this data into my model. So basically,
so what is the use of gyroscope and accelerometer data? Because we are recognizing the human
activity, right?
Yeah, human activity.
Yeah, so those activities are actually recorded by the things. I told IoT, right? So things are the sensors. So
they were sensor present like
right,
gyroscope and accelerometer.
So those accelerometer and gyroscope, those are actually embedded in smartphones, and the data recording was done using smartphones tagged at the waist of those 30 persons. So if those accelerometer data, so obviously you will be getting some values like some 5.6 or 7.1, 8.2, something like these. Those you will only be getting values. You will not be getting some activity like whether a person is standing, or those are the categorical variables, right? So those are the categorical variables labeled by the participants. But the data that was recorded, so that was in terms of these XYZ numerical values. So these XYZ, because the computer will understand, the code will understand the numerical. So those sample values, and that is recorded for few minutes. So as that values were required, so that is a time series data, and that's why we have used the LSTM model. So this is the way these 3 the last 3 functions that I showed, this diff, load file, load group, and load data set group. All these things are done to you can do it in your way also. But this thing suited to me, means for loading the data set, means for grouping, for visualizing, and then feeding the data set. Next, after I have grouped those sample values, I have just loaded the data set. So here diff load dataset, this is another function. If you can see, I have written here load the dataset, returns train and test X and Y elements. Now I told that there are 6 activities, right? So at the output, so those are the categorical variables. But here these train X and test X, these are the values, the input values, those total X, acceleration, and gyroscope values. But corresponding to those training and testing values, obviously there needs to be some particular levels, right? So those are this train Y. If you see here, train Y and test Y. Okay, so these are the values that those are the labels. So 6 activities means 0, 1, 2, 3, 4, 5. So those are the labels in these train Y and test Y. Now, how will the computer understand there's 0, 1, 2, 3, 4, 5, whether those are the numerical values or whether those are categorical variables? So I don't need, I mean, here those, by telling 1, 2, 3, 4, 5, I am not meaning anything quantitatively, right? So I'm meaning them categorically. So that's why, to make the code understand that those are categorical variables, I have to take this thing, this 2 categorical train y, 2 categorical test y. This is called as one hot encoding. So one hot encoding means every value, like for 0 you will be having 6 0 0 0 0 0 0 0. Then for the first level you will be having the level as 0 0 0 0 0 1. For the second level you will be having 0 0 0 0 1 0. So like this, the 1 will fall in the place of the, I mean, the level that you are assigning. Okay, so that's why this is called as one hot encoding. So this I am doing, and then I am returning the shape of the data set. I am printing the shape of the data set, train x dot shape, y dot shape, then again the testing data shape. Next,
so we are using train and test data for training the model and testing the model, right?
Yeah. So I have already, the data has already been split by the by the data, the people who have created the data set. They have already separately segregated the training data and testing data. Generally, what we do, for an entire data set where it is,
why we are giving the labels for train x and test x?
Yeah, that I am telling, because here I need to first train my model on some label, on some data that is having some particular levels, right? But since this is an application program where I need to see how well my model is performing, that's why this is an existing data set. So that's why I am having the test levels here to see how well my model has performed, predicted on the unknown data. Now this training is done on known data and testing is done on, generally this testing is done unknown data, right? So that's why it is called as train and test. Test is, obviously, you are right that why we are providing, this question is obviously bound to come, that why we are providing the levels to the testing data. But here, since it is an existing data set and we need to understand how well the model is performing on my test data, so in order to see how the predicted values, the outcome, how is it performing, to test my test to get my test accuracy on some unknown data, I am already feeding my test data. But to my model, when this is the data set I am loading, but if you see, when I will be finally getting the output, there only I will be feeding the training data. I am coming to that. See, after till now, what I have done, I have just fed the data, and then I have loaded that data, and that loaded data is now fitted and evaluated through the model. Now this part is the evaluation part. See here, this is the function called def evaluate model. I have given here train x, train y, test x, test y. But let me explain what is this verbose, epochs, and batch size. This epochs and batch size, these are actually, the epochs is the number of times the model will go through this, will see the entire data, and batch size, if you remember, sir told something called the gradient descent and stochastic gradient descent, right? So there is another thing called mini batch gradient descent. So mini batch means small batches. For the entire data, I am separating into small batches. So here I am having say I am having 3,352 samples. So out of that, I am feeding to my model 64. So this is an hyperparameter, batch size and hyperparameter, which we tune. This is in this code specifically. We have just changed this batch size to see at which batch size the model is performing the best. Now verbose, that is set to 1, because at the output, when I need to see every step, I will show it later. If you see that these are the number of epochs, those, in order to visualize that thing, that epoch 1, epoch 2, epoch 3, in order to see that thing, you have to put verbose equal to 1. If you put here verbose equal to 0, in that case, you won't be able to visualize the epochs. Means what in say you are running for 100 epochs. I am running here given the epoch value as 100. So what is how much accuracy was there in the 50th epoch or 60th epoch? You won't be able to understand if you put verbose equal to 0. So that's the reason why we put verbose equal to 1. Next, here the times as I have fed the data here, this train x in the train x matrix, train x dot shape 1 in the index 1th position, means it is a 3-dimensional, right? So 0 1 2. So in this 1th position, in this the second position column, so there is the time steps. I am having the number of time steps. Then features is my train x dot shape 2. In the third column, I am having the number of features. Those features, as I told, those 9 features. Those total acceleration x, y, z, then body acceleration x, y, z, and gyroscope x, y, z. So these n features. So that is stored in train x dot shape 2. And this n outputs, there is the train y dot shape. Now, if you see here, I am not feeding the test data, right? So I am only feeding at the input in the evaluation part. I am although I have in my data set I am having test x, test y. Here I am only using train x and train y in my evaluation part, and based on that I will be testing my test x part. Okay, so now you are actually in this next in this part you are actually designing your model. Means designing means you are actually fitting your model means doing the architecture of your model. So this is actually sequential model. So in the first layer I am adding the 100 LSTM. This is the number of LSTM layers. So this thing I have put as 100. So this is also a trial and error thing. So you have to see. First, you may start with an arbitrary value of like 50 or 60, and then you see whether how the performance is going on. And then next you have to decrease. So this is actually somebody told that time hidden layer. So these are actually the hidden layers. This model.add. The number of times I am putting the model.add, this many hidden layers I am having. Okay. So 1, 2, 3, 4. So in the first stage I am having the LSTM layer. Next I am giving a dropout. Dropout is given 50% dropout I am using. This is actually a kind of regularization thing. Okay. So regularizing thing means in order to prevent the model from overfitting or underfitting thing. So overfitting means when the model performs good on the training data and performs bad on the test data. So that is unwanted, right? So means when you are getting the known questions in your exam, so you will be obviously performing good. But if you are given unknown questions in your exam, you will be performing bad. So that is not desired. So the learning thing has not happened. So that's why I need to put this. I have used a regularization technique called dropout. So that thing is used after the LSTM cell. And then I am using the dense layer of 100. Dense layer is nothing but only an ordinary neuron, perceptron. A single neuron actually. So where all the things are actually connected one after the other. So there are 100 such neurons which are fully connected to each other. And then there is another layer where the final output layer, you see this dense, the n outputs, and activation here I am specifically using softmax activation. So in the previous hidden layer I have used activation of ReLU. So these are the different activation functions. Okay.
So can you explain softmax?
Softmax. Okay. So softmax is something. So here there are 6 classes, right? So as I told. Now if you would have do you know sigmoid?
In output we have 6 classes.
So do you know sigmoid? Do you know sigmoid?
Yes, sir. Sigmoid forms.
Okay. So if there were 2 classes at the output, so the output would have been sigmoid, right? So because 0 and 1. So what is a sigmoid? 1 divided by 1 plus e to the power of minus x. Okay. So that is sigmoid. Sigmoid. Now since here we have 6 classes at the output, so obviously sigmoid will not play any role here, but a similar thing to sigmoid of binary class. In multi-class, we have to use softmax. Sigmoid softmax is actually a big brother of, I mean, sigmoid. So for sigmoid you have binary class, and for softmax you have multi-class. So it
multi-class. Okay.
So it is given by the formula. You can get in formula in net also. So e to the power of I divided by sigma of j equal to 1 to I. So j equal to 1 to 6, or here it will be 6 actually, e to the power of j. So means here sigma for a particular class, it will be having one sigmoid at the output, one exponential at the output to the power e to the power of that class divided by e to exponential to the power of all the classes. So that is the thing here. Instead of 0 and 1, you will be having 1 to 6. Okay, so that is the same thing as sigmoid, but here you have 6 classes. So that is the activation here. Got it? Okay.
Yes, sir.
So next, after we have put the models, so next we are compiling the model. Here, sir told that the mean squared error loss, I think in his explanation you have noticed. So here in LSTM, we are using a cross entropy loss. So categorical cross entropy. So if there were 2 classes, we would have used binary cross entropy loss. Okay. So here this categorical cross entropy, because we have 6 classes, and categorical cross entropy loss is given by the formula minus of yi of log of y hat I. So yi is your yi is your target variable, and log of y hat I is your, that y hat I should be your predicted variable. Now also you must have noticed that sir told something called as Adams optimizer. Okay. So these all are used to make the model perform better, to tune the model. So here we have used the Adams optimizer with a learning rate of 0.001, and there are other parameters also, like those beta 1, beta 2, so epsilon. So those are the actually used here. So here I am plotting the model first. So
what does optimizer do?
Optimizer, see, as I explained, the regularizer, the dropout is a regularizer. Similarly, an optimizer an optimizer also optimizes the model. Means if you see here inside, we have put the learning rate. Then just a minute. Here the decay ratio. So here, inside, as you can see, this inside the optimizer, we have put the epsilon, decay, beta, learning rate. So these are tuned. These values are tuned. Specifically this learning rate, this is tuned to make the model perform better. So you have to optimize these terms, this learning rate. Beta also you can tune. Beta 2 you can tune. So these values you have to settle first. Generally, we tune this learning rate.
Learning rate is like hyperparameter.
So these are actually a hyperparameter. Inside this optimizer, you have this learning rate. So this hyperparameter. So inside this optimizer only, you have to tune this hyperparameter. Okay. So by specific from outside, just like batch size, you can tune separately. Okay, batch size and epochs. But these hyperparameter, this learning rate hyperparameter, you have to tune from inside the optimizer. Okay, so that's, since there are a number of terms you can optimize, so that's why it is called an optimizer. So like similar to Adam, there are also other optimizers you can take, like RMS prop, then AdaGrad. There are many other optimizers also, but generally in general we use Adam only. Many people use RMS prop also, which is a combination of this Adam and the SGD. So, but many times we use this Adam. You can, you can try your hands with these with the different optimizers. Okay. So.
Okay.
So next you are plotting the model. If you want to plot the model, you can use this plot model thing. Then you will see that I am plotting something called model summary. So I will show you that after this thing, this model.summary, how I have plotted it to have a visualization of all these hidden layers and all these things. Next, history equal to model.fit. So these model, after you have designed the architecture of the model, next you are fitting the model inside this model train X, train Y. Then epochs equal to epochs I have put. Epochs is equal to actually 100. So those 100 I have already fed earlier. Here I have already put here epochs equal to 100. So it will take epochs equal to 100. Next, validation split. Now the training data is designed further splitted into the sub training data and the validation data. The validation data, these hyperparameters that we are putting here, those are actually working on the validation data. This validation split equal to 0.3 I have put. So what is this? This is actually 30% of the entire training data. So on that 30% of the training data, I am working with these hyperparameters. So not on the entire training data, mind that. Only on this validation data, these hyperparameters will work on, so as to get the maximum training accuracy. Okay, so I will be plotting both the training and the validation plot, as well as also I will show the test accuracy values. So this is the validation split. Next, batch size I have put, verbose equal to 1 I have already put earlier. Next, shuffle equal to true. Shuffle equal to true means this value will be shuffled. Means say you have 10 samples. Okay, so first 5 samples are of class 1, and from 6 to 10 say you have class 2. So if you don't shuffle, the model will be biased. Means for the first 5 classes it will see that it is having class 1, and from 6 to 10 it is having class 2. So in order to prevent that, your entire entire data set is shuffled. Means after 1 then comes say 5, then after 5 say comes 2, after 2 then comes 3, like this. So that's why you have to put shuffle. You're shuffling the entire data set. Okay, so next I'm printing the history of the, I will print the history, and then the validation and the accuracy and validation accuracy also I will print for I in D. Means this is a for loop from where means both accuracy and validation accuracy I will be printing for the entire data frame. Next, these are all the plotting things, these history and these tables. I will be showing you these things. Then next, these metrics. If you see this white, so
the validation data is like a training data. We cut out from the training data.
It is a subpart of the training data. It is a subpart of the training data. So
like 30% of the training data we are using for validation data.
Exactly. That subpart of the training data you are using on the validation, for validation purpose. Not the entire training data is used. Only that validation data is used for training. I mean, sorry, for
it is already not separated in the data set.
No, it is not. Exactly. You have to put the validation split. You have to put that.
Okay. And we have to shuffle the validation.
Exactly. Put shuffle equal to true. Then only the values will get shuffled. If you put shuffle equal to false, it will operate, but the model will not be good.
Okay.
Next, this is the here y true and y predicted. So these are the values that you will be printing. These y true and these are actually the true values, and this the y pred, this is actually the predicted value. Next, this matrix, this confusion matrix you are printing. So here this confusion matrix formula we have put here. Just invoke the from matrix.confusion matrix. When the test y.argmax in the axis 1 we have put this. You can, this is on your own, you can decide with on which axis you will put what. So on both the axes I have put here this test variable and the y means along the multiple lines. So I have put this thing test y and y predicted in the confusion matrix. So here also the other values, this precision, recall, and similarly this F1 score. These now I have finally run the experiment here. After I will run the experiment, you will see that thing. First, this thing.
Sir, you have written all the code like continuous.
Which
you have
one?
not splitted the code, right?
No, see here one part.
You
These
are
are
running
actually
the code
subparts.
all. Yeah.
So
You are
no, till this part I can run now, but this last part, if you see here, for each epoch, it is training. It is taking
like
a
when I used to build a model, I used to run part by part the codes.
I have also run part by part. See here 7, 8. So these are the code snippets in the thing. So this feat model is actually a big thing. So here I think you are confused because of this big part in this inside this one part only, in this evaluate model only. So if you see, all parts are separated, 5, 6. In fact, I am also means anybody of us will who do the code in Jupyter Notebook or in Google Colab. Everybody does this thing in part by part only. I mean, it is better to do part by part only, not entirely. Like in Spider, you have to do the full thing only. Okay. So after I have run the experiment, if you see here the data set, I have printed the shape first. If you remember here, I initially here if you see print train x.shape, train y.shape, then text x.shape, test y.shape. So this was the first thing that I printed. So here you see that 4 things are getting printed. Training, this is the training data, and this part is the training level. So what is this? 7352 is your number of samples, 128 is your total number of time steps, and 9 is your number of features. Okay, input those acceleration and gyroscope thing. And this one, along this axis 1, initially I am having for each of the 7352 samples, training samples, I am having this level, the level on the first column. So for one in one column actually. So that's why this 7352, 1. And my testing data was consisted of 2947 samples of each of 120 time steps and 9 features. And similarly for those also, on one column I have put the labels. But when I'm printing them at the output, so since there are 6 classes, so I have modified those along those one class along the first axis. Although I had the all the target variables, so the target labels rather, at the output I am now having 6. You can see, so because there are 6 output classes, so I am printing this shape at the output. Similarly for the testing part also. Now after you have printed the shape, you have fed the model, right? Then you have printed the model summary. So here if you look at the model summary, here see these are the hidden layers. So first you are having the LSTM layers, and here the number of parameters is also getting counted at each layer. So this is actually the number of weights and biases. Those are the parameters, not hyperparameters. Hyperparameters are those which you can tune, but parameters which get updated on their own. So these are the weights and biases. So these are actually the parameters. So in the LSTM layer, there are 44,000 parameters. In the dropout layer, nothing is there. In the because that is some kind of regularization thing. That's why. Then in each of the first dense layer, there are 10,100, and in the final dense layer, you have 606. So total parameters. This will give you a computational complexity of the entire model. Okay. So these are the total number of trainable parameters. Next, when you have run the model, since I have put verbose equal to 1, so it will show you at the values of every epoch. So I have run for 100 epochs, right? So 2, 100. Now you notice one thing. Here you are being shown as 5146. So what is this 5146? I have told you validation split is 30%, right? So my training sample was 7352. Okay. So 30% of this 7352 I have used for validation. So the rest 70% of those 7352 is used for training. So that is only those, that is 5146 is 70% of 7352. Okay, so I have trained the model. So for in every epochs you will be getting the training and the validation accuracy as well as the loss values. So like this you have run the entire thing, and finally we have got a curve of training and validation. So this plot you can get if you want to get a better plot for your publication papers and something. You can import these values in an Excel file, and then you can plot in MATLAB also. Now that confusion, the test accuracy finally I have obtained as 90.56%, and this is the, see there are 6 output, 6 rows, 1 2 3 4 5 6. This is the confusion matrix actually. So this gives you an, although you can calculate the precision function, recall and F1 score, and I have printed these values. So similar to this LSTM, you can use the thing for the CNN also, and the other deep learning models also. So this might be a bit of high level thing, the LSTM, but if you see, LSTM is an existing thing, and there are a number of codes you can see from Kaggle and GitHub. So the number of data sets are there, so you can implement from there. So I just showed one thing to you in this short period of time. So any questions? So that's it from my end. If you have any queries. Any queries? Hello? Mm-hmm.
Thank you. Goodbye. Stay safe. Sure. We are not met for the last 2 years. Yeah, sure. Thank you. Pritham is not the faculty. You can not call sir. He is the student. He has just submitted the thesis. He might become faculty. Okay. ठीक है.
Thank you, sir. Thank you, sir.
हाँ ठीक है.
सर हम लोग के पास रजिस्ट्रेशन नंबर तो नहीं है सर. ठीक है.
Sir, will this webinar will continue or not? Yes, sir. सर कोई दिक्कत नहीं है टॉपिक का, टॉपिक सारा चलेगा, मतलब कुछ ना कुछ सीखने को मिलता ही है। यस यस।
Yes.
ओके, थैंक यू।
Thank you, sir.